There will be leagues, we're gonna be more after that, but it shouldn't be too big. Just being a business. And the Rutgers book, which is a lessons and dots. I'm just getting started. So what this is gonna be on is the all members of ASME family. That's pretty much it, which is nice so far, and we'll do some classifications. And we'll also go over like, their molecular forces. So. This is. Small classes. So we'll be naming it with the ending. Of acid. And so if we have carbons. 5. We have 4 methyl. And 9. We have some questions about that. Remember, it's only oleic acid that has this OH. If not, it's gonna be OH. We have this one. This is actually ionic bond, so we're gonna name it like a salt. If you're we're naming a salt, positive ion comes first. And then. 4. 2. Three. And. Thing that's attached. First. And this is second. And this doesn't get cis or trans because it's on the end. And remember. Look at a double bond like this. The rest of the bond, go. These two are the same, so it can't be cis or trans. So yeah. This is one of the rare cases where you don't. Any questions about this?
But can you repeat why we don't put sister chains?
Right. So double bonds. We're looking like split across the middle. You can look at this one here too. So this has an H. This is the bigger group. So this would have the dominance. This is the bigger group. So they're trans, they're going in opposite directions. This one here, we don't know which one is the bigger group. So it can be cis or trans. And an easier way to remember it is just, if it's on the end, it can't be cis or trans. Any other questions about that? Let's go to the next one. This one here. This one, drop this one. Oh. Purple. Apple group. That I already count. 1, 2, 5, 6. So we have. Friends. Purple. 2, apple. X. 2. Oh. So these ones. So the chances first. And purple. And then the rest. Also write. X. Whichever you prefer. Yes.
Do you not have to specify that the purple is attached to the oxygen? So it's the purple,
Nope, so you only have to do that with the nitrogen, which I know is weird, but. It's less you have to write, so this one, the 08 is enough to designate. Just like you don't need to put like O potassium. Any other questions about this? And so this group, I forgot to label it. This is an ester. Just a reminder. This is an ester. Yeah. It's a very common mistake. You'll get like half a point off, but they are different and it's important to know the difference. Any questions about that? So. This is an amine. Which is different from an amine. We haven't learned about amines yet, we learned about that later. So an amine, pardon me, is a double bonded oxygen. The carbon, and then it's attached to it. And then these are classified by how many carbons they're bonded to. So. This only has one carbon attached to it, so it would be primary. I'm gonna erase this. Secondary. It's just about how many times that nitrogen is bonded. Any questions about that? You could probably, if you want to use name the nasty classifier. Please do not get classifications. So you do not have to worry about classifying. Only these will be classified. I'm gonna start on. 4, 5. I have a hydroxy group. And I have an isotope group. And there's nothing on the nitrogen, so I don't need to put anything. So I just get to start out with the name. And this is not cis or trans. The easiest way to tell is it's on the end. So you don't need that. So. Hydroxy. 3-isopropyl. Any questions about this one? This alcohol can't be classified as it's bonded to a carbon that has a double bond. So she would not ask you to classify that one. We also need to remember some of our relations again. Our benefits. Passing. Experiment. Let me get tiny up here. These are our base ones. These are the actual name, this one you plug in, whatever the R group is. And really quickly, just to go over the molecular forces. And this one, hydrogen bond.
Be accepted, but not doing it.
Yeah, can't do it. But a lot of these can. So, in solution, this is going to be a soluble. Just to make connections, foreshadow. So this right here, oh. Sorry. Do that. It's all me. And screw and a mean. So this has NN dimethyl. And that goes in front. Now it makes it different than these is that it's in parentheses. It's on a nitrogen. So it's not a special like in its own potassium, like propyl. This tertiary mid, it's 1, 2, 3. This cannot be orthometapara because there's more than just 2 things on it. 1, 2, 4. So then we have 3 or 4. Pineapple.
You have to put the first part in parentheses or no?
Yes,
Okay.
this is in parentheses. This stuff is not. Why is it doing so? Oh. Right. It should be too long. I even have it. Are you writing down the slides? because there's two methyls here attached to the nitrogen. It's the NN dimethyl. Then there's two attached to the animal, so before
And why is it NN?
is attached to the nitrogen, these two are. These two
Oh,
are.
both of the methyls are attached to okay.
So. This comes first dimethyls, these two. But. Methyl, and that will be our fat helps. And these are also. Then two, four. Any other question? It's got that. Ready to erase. So this one, since there's only two things on it, you can use orthometapara. So. So this goes first. Is it purple? What is it? There's some purple. This is fine, different from when it's a. This one we put this first. Plus the hydroxy. That's like numbers, so let me compare with the hydroxy.
Does the blank go before the isopropyl?
So when it's on the ring like this, it's different than when it's in a line structure. So the isopropyl will go first, then it's the ortho, because it's taking place of a number. Does that make sense? So instead of writing 3-hydroxy, you're putting ortho there, which is why it's attached here instead of in front. The isopropyl is in ortho.
And the hydroxyl be added.
Oh my gosh, yes. It's that. Did that twice today where I have it labeled.
I was scared for a little bit. I was
Yeah.
like, is there a rule I don't know?
No,
Right stuff.
right there, the letter's right there. it's not overrated in that space. Yeah, but you wouldn't be using that, it would be like cis for trans.
So that always is, like, you can see some trends in that goes for less global.
Yeah, because that doesn't, yeah, like this is a number. This could be 3. But she'll want you to write that up.
Do you put the dash like you would a number?
If you do the M, then yes,
Okay.
just do
Not
that
then
other
you
now.
just write it.
That's why I put it up here. Any other questions about this? Remember? This is an ester. So it gets to benzoate ending, not benzoate. And if this wasn't here, it would be a phenol. Go to this. Aniline. That's a secondary. Oh my gosh, I can't. A minute. It's connected to 2 carbons. And it has 1 hydrogen. 1, 2, 7. Alcohol. This is trans. I have a purple. And then it's a alkene. So. Trans goes first. Different than this. Again, this isn't a number. Trans. Then the purple. Go over here. Or ethyl. At 5. Or 5. Again, this is the only one that can be classified. This is on a benzene, so technically it would be benzoic, but you don't need to know that, it's not really classified. That's not primary, secondary, or tertiary. This, also on the benzene. Anyone have any other questions about naming? We're about to move away from naming.
Just like write all the prefixes, what the suffixes.
Oh, sentences. Um, way back. I'm not going to erase this. I can make that up for a bit. Well. So the ones that she's gonna have you compare are gonna be carboxylic acid, ester, this could be like an aldehyde. And then she'll have you analyze the different amide types, the different processes. So it may be a bigger molecule than this, I'm giving pretty much the most simplified form. So, here quickly. We go over dipoles, so. The dipole there. It's double bonded down, pulling that part up. And all of you being pulled in the direction. And it's oxygen. So this has 3 dipoles going on. And I should do a better job in this look. But so just like carboxylic acid. There also has 3 dipoles. Then aldehyde, phenols have. So what these all have in common are the double bond. Because remember in naming, the priority, I'll write it at the top. So we have the acids. Then we have aldehydes. Ketones. Alcohols. So these acids are now on top of naming. That's why we compare them. Each bonding. So what's nice is that we know none of them are ion. And because they all have oxygens. And now only have dispersion forces. They have dipole. Oh. So this one only has 1 dipole. This one has 3, so I'm gonna check it 3 times. And this one also has. You don't actually have to do it like this, but it helps you remember how many intermolecular forces. So we're gonna do this with boiling point first. So this is when it's flipped against itself. So carboxylic acids have that oxygen bond to the H, so they can H bond to themselves. Is there a hydrogen bonding in this one? Then there's that. And so if you had to rank in terms of boiling point, this one is the highest. Because it can hydrogen bond, but also has the 3 dipoles and has dispersion forces. This one has 3 dipoles, making it second. And then dispersion forces obviously. This one only has 1 dipole. And it has dispersion making it third. So the same pattern would follow for solubility, but we'll adjust the chart a little bit. So I'm gonna erase the H bonding. Because this is what changes. Alright. So This one, since it could H bond before, you know it can accept. And. Making it still number one. This one over here. Actually has two opportunities. To accept, so I'm gonna put two checks. So it's not as powerful as donating, but the H can interact. With the O or the O, it has two opportunities. This one here can also accept. It only has one oxygen. Meaning it can only. H bond once.
We're not gonna have to do that for the fifth one, so.
Yeah, so you'll have to know how to rationalize it. Technically, you don't have to put get the checks, but you should write accept. Only. You should know, still ask you about it. But you don't have to go as that. Now, if this were. This were assault. Right? Then it would have. Ion. That would immediately become number one. It would not be able to H bond. Right? It wouldn't be able to H bond to itself. Still, but it has the ion combination. Any questions about the comparison between the three of these? Going to the research, yes. Yeah, so if the original molecule has hydrogen bonded to an S, an O, or an N, then it can accept the endo. But if it's just bonding to itself and it doesn't have, there's no hydrogens bonded to an L. So it can't hydrogen bond. But if it's in water. It's able to accept it, because water can always hydrogen. So only when it's in water can hydrogen bond, and that's when we clean just by accept. If it was by itself, it would be a thing. Any other questions about this? Maybe two of this. Bye. So another thing that she may ask you, it's either gonna be one or the other. If you're gonna make you draw both, I don't know if you do that, but. You'll either have to compare the amides or compare. The. Acid, ester, and. So if we were to classify these. This one would be primary. Secondary. Tertiary. We're going off of how many primaries it's allotted. So. Starting off the chart, you see. Now ion. All of them have dispersion. And let's go through and draw the dipoles. There's one here. There's 4 dipoles total. This can be said. Over. So all of them have the same amount of diamonds. So I'm just gonna give them all the same shot. And so, what makes them different is their ability to hydrogen bond. So remember, we need a hydrogen bonded to an F, O, or N. So now we're gonna be looking at how many times a hydrogen is bonded to a nitrogen. So in this case, the oxygen isn't bonded to any hydrogens, but there are 2 hydrogens bonded to nitrogen. And so if this is boiling point and if it was with itself, it would have 2 places where it could hydrogen bond. Over here, we only have 1 hydrogen, but it's still bonded to that nitrogen. And so it can't hydrogen bond. This one over here, there's no hydrogen bonded to oxygen or nitrogen. So it would not hydrogen bond. Again, this is boiling point when it's put up against itself. The only difference for solubility, because water can hydrogen bond, is that now all of them can hydrogen bond up here, right? Water's polar, it's still bond with this oxygen. And then this one will be able to hydrogen bond now, but it cannot donate. Accept. So this was. Small. Solubility. This would be accept. This would be. Acceptability. Does anybody have any questions about this? If not, then that's pretty much everything. I know it's a lot to remember with the naming, there's a lot of new naming to know, but they all follow pretty similar patterns, as long as we pattern down. And then this chart is the same thing you've been doing all semester. So just trust your gut, you know what you're doing. You do them all quizzes and exams all the time. Everybody have any questions?
Yeah, she great.
They worse or better. Same. Same is better than significantly worse. Here's a. Over here. Over the minutes. Oh, yeah, so. Analytics basically an amid benzene.